Hello everyone. So in this video, I want to just briefly describe how we use the human arm model to collect the data. So we have this mechanical model, right? It's what we consider to be a functional model, right? It's not exactly anatomically correct, but it gives you the basics, like basically the length of the forearm and hand, the length of the upper arm. It's pretty consistent, right, with say an average adult. There's some things that are different though, like the mass of this little metal forearm is not equivalent to the mass of an actual someone's forearm, right? This is going to be a lot less. But for the most part, it models the most important things. In particular, we have this rope here, right, that connects to the forearm, and it passes around the shoulder. And basically, we have a force sensor here where we can measure the tension in that rope. Well, this rope is going to represent our elbow flexor, okay? Now, I know in reality, again, we have more than one elbow flexor, right, that spans the elbow joint. We have certainly biceps, I guess brachialis, brachioradialis. So there's several muscles that span the elbow joint, but in order for us to compute a value theoretically, since we're going to have one torque equation, we can only have one unknown force. So you can think of it as like the biceps force. Those three forces together are kind of combined into one force. In this case, it's going to be the tension in the rope here. Okay? All right, so how do we collect the data for that first table? Well, the first thing I do is I want to zero this force sensor when there's no force in the biceps muscle. So I can lift up the forearm and hand, zero out the sensor, and then let this drop again. By the way, I have this set up at around 90 degrees. So basically you can think of this person as doing an isometric contraction where they're holding their forearm at 90 degrees, right, relative to their upper arm. Their upper arm is just hanging straight down. And we want to calculate what the biceps force is while they're doing that isometric contraction. Okay, in this case, there's no load in the hand here, so it's basically just the weight of the forearm and hand that's providing that force. And using the GLX device, I can read off that force value. So it's saying that the force in the string here, right, the biceps force, or the tension in the string, is around 3.59 newtons. Now, what I want to do is I want to increase the load in the hand and keep recording that force. So in this case, I have 25 gram mass here, which I can convert to a weight, right, in newtons. And again, I'll explain all that in another video. I can put this in the hand, let it stabilize, and then I can read off that force value, 5.64 newtons. Then I add another 20 grams. So now I have 45 grams in there. Again, I can convert that to newtons, and I would read off that force value. So now, again, I'm reading off the tension in the string here. So think of it as the biceps force. So really what we're doing is looking at how the biceps force changes as we increase the load in the hand. Okay, so that's the basic idea of how we actually collected that data. And again, I'll give you guys all that data in the lab handout, but that's how we collected the data using that human arm model. Great, thank you.